we'll see. So if the degree of numerator is bigger than degree of denominator, then we have no horizontal asymptote. So to do this correctly, to take you through how to sketch rational functions, to do it properly, I'm going to have to actually show you 3 examples so that I can show you each of these 3 cases. All right? So we will compare the degrees and we'll figure out which of those it is. That's step 4. Step 5 is to plot all the information you have and sketch it. All right, I think we should try an example, don't you? By the way, I will provide you these steps on the test, okay, because this is a lot to have to remember, all right? So let's do an example. And why don't we do that example that we started with? X plus 4 over x minus 4. All right, so the first step, it is a rational function, so check. The second step, maybe I should see about, yeah, maybe I should see about just copying this over here. So the first step, it's a rational function. Second step, we're going to find the x-intercept. So we're going to set the numerator equal to 0 and solve. So for the x-intercepts, we will set the numerator, which is x plus 4, equal to 0, and solve that. So we subtract 4, we get x is 4. Now remember, this is going to be a point on the x-axis, right? That's going to be a point that's on the x-axis. Why is that not going? There we go. Okay, step 3, find the vertical asymptotes. I'll do that over here. Step 3, we're going to find the vertical asymptotes. And to do that, we will set the denominator equal to 0, x minus 4 equal to 0. And add 4 to both sides, you get x equals 4. Now remember, this is not going to be a dot on the x-axis. This is going to be a vertical barrier that we are not allowed to cross. It's going to force our function up or down when we get to it. Then the fourth step, the hardest step, the newest step, the horizontal asymptotes. So let's do this. We will compare the degrees. So let's go back up and look at our function. The degree of the numerator is 1. The degree of the denominator is also 1. So it says here in the steps, if the degree of the numerator degree is smaller than denominator, that's not what we have. They're the same, right? So it's not the first one. The second one says if the degrees are the same. Well, I can't type. Are the same. Then the leading coefficient of the numerator divided by the leading coefficient of the denominator is the horizontal asymptote. Okay, so since we have the same degrees, I'm going to look at the leading coefficient on top, which is a 1. And I'm going to look at the leading coefficient on the bottom, which is also 1. And I'm going to create a fraction out of those, 1 over 1. And what is 1 over 1? Well, just 1, right? That is my horizontal asymptote. Any questions up to this point? Found the x-intercept, found the vertical asymptote. Those are just setting things equal to 0. The horizontal asymptote, I compared the degrees. They were the same, so then I had to go look at the leading coefficients, make a fraction out of them, 1/1, and that gives me the answer of where my horizontal asymptote's going to be. And now all I need to do is sketch it to plot all this information.
Just real quick.
Yep.
When you say degrees, you mean the powers?
Yes. Yeah, when I say degree, I mean power. The highest power. The highest power of X. Okay, so let's try and draw this. This is where things are going to get real weird. Graph, and it's on the x-axis at 4. 1, 2, 3. Wait, hold on. That was a -4, wasn't it? Right there, that should be -4. I subtracted 4 on both sides, but I don't know why I wrote 4 down. That should be -4. I'm glad I caught that now. 1, 2, 3. It should be the other way. -4. We should have a dot here. Okay? Any questions there? The next thing I have is a vertical asymptote of +4. So now what I'm going to do, and I said I was going to draw my function in blue, so I've got to erase that dot and make it blue. So that dot was part of my graph. Then I'm going to go to +4. And what am I going to +4? Not a dot, right? What's happening at +4? I have a vertical asymptote. What are vertical asymptotes? They're vertical barriers functioning across. So they're actually not part of the graph. So I'm going to actually do this in a different color. And I'm going to make a dashed vertical line that's going to represent that vertical barrier. I know that as I'm drawing my function, if I get to that vertical barrier, I'm going to have to turn up or down, one or the other. And that's going to be a little horizontal asymptote of 1. So horizontal, right, is this way. So if I go to the y-axis and I go 1, if I draw across, here. So watch how I do this. This is super critical that you do this. I'm going to go like, here's 1. I'm going to go to the side here and draw my dotted line out here. And then the left, I'm going to go out to the side here and draw it over here. Notice I'm not putting a dotted line across the middle. And the reason I'm not doing that is because the horizontal asymptote ends. It tells you nothing about what's happening inside. So just draw it out to the ends. Now, this is the hard part. This is the hard part. This is it. This is all the information. So now we have to draw this. We have to draw this. And this is where things can get really tricky. Right now, we only have 1 point, don't we? I'm going to highlight it right now in this blue highlight. That is the only point in this graph. Okay? Can somebody tell me if I were to go from that point to the left, what I would have to do? What do I have out there to the left of that point?
Horizontal asymptote.
Yeah, a horizontal asymptote's over there. And doesn't the horizontal asymptote act like a magnet and pull the function towards it? I'm going to draw my function going up towards that dotted line, and then just like that. I'm not going to touch. Now, what if I go and I try and draw now to the right from this point, from that point right there to the right? Somebody tell me what I think is going to happen. Just imagine I'm drawing to the right here. Draw to the right, draw to the right. What's going to eventually happen?
You
What
can
am I
do
gonna
cross-
run in?
the
It's gonna cross
vertical
four.
asymptote.
Yeah,
So it's gonna go
that
down.
vertical, right? And the vertical is either going to force your function to go up or down. So this isn't a coin flip. You don't get to guess. And can anyone tell me what it has to be and why? Like our two choices are to turn up or to turn down. And the important thing is, which one is it and why?
We're gonna
Up
go
or
up
down?
because X4 is positive.
So you think it goes up because 4 is positive? Okay, that's a decent guess as to why. Ideas on up or down here?
Down because it can't touch the 1.
Down because, okay, close, very close. Down because it can't, you said because that's what you were talking about, is that horizontal one right here?
Yes.
Yeah, okay, so remember I said to only draw it on the outsides, right? Because I don't want you to think you can't cross it. You can't cross it on the ends. So you're incorrect in saying that you can't cross the 1, but something. If you go up, what happens? What do you cross? What's that right there? What did we just create? Right,
X-axis.
the x-axis. But what's the only x-intercept I have?
-4.
At -4. So you are not allowed to go up, because if you go up, you'll cross the x-axis and you'll create an x-intercept that doesn't exist. You don't want that. So it tells you you have to have gone down. So it's going to turn and go down like this. Okay. So if we were to kind of just back up, we're not done, okay, with this graph, but if we were to back up and look at it, we knew which was this one. We said if we draw to the left, we have to get closer to that dotted line, so we have to go up here. And if we draw to the right, we're going to run into that barrier, and we have to go down, because if we go up, we're going to hit the x-axis, which we're not allowed to do. That's a graph that we have to draw over here in this region. So if I had to draw this graph, can anyone kind of tell me what I'd have to do? Can a graph be down here anywhere?
No.
No, because what does that dotted green line tell you right here? What is the dotted green line telling you?
You cannot cross.
Yeah, but it's a magnet. It's pulling the function towards it, right? So the function has to flatten out towards that. The function is going to have to be over here somewhere, flattening out to it like this. Now, you could have done something like this also, right? But what would happen as you try and draw this to the left? What's going to happen? Let's take the one on top. If I draw this to the left, what's going to happen? Here comes the barrier, right? So I've got to go up or down. Which way? Which way and why? Could it go down? What happens right there?
No, because the horizontal is putting it towards it, so you won't be able to go down. You have to go up.
Well, when I drew this down just now, what did I just do right there? What did I create?
You made another X.
I made an
X point.
x-intercept, which I can't have any x-intercepts. That's the only reason I can't go down, is because it creates an x-intercept that doesn't exist. We have only one x-intercept, right? We do this, draw it this way. We're going to create another one. That's not what we have. Let me take that down. So that means that our graph has to turn up like this. Now you could have done this. You could have done this one on the bottom and then turned it up. That would have been fine. Both those on the right would be acceptable answers, but it has to be one or the other. It can't be both. The important thing is that whatever you draw over here, don't come creating X-intercepts. See how I created 2 X-intercepts? Can't do that. Would you all agree this is a little bit difficult? Like there's a lot of thinking that has to go in. It's not just like step 1, step 2, step 3 done. It's like, okay, how do I put all this information? All right. That's the graph right there. Okay. Let's do another one. Is this a rational function? Polynomial divided by polynomial? Yes. 2. Let's find x-intercepts. So how do we find the x-intercepts?
Make it equal to 0.
What equal to 0?
2x minus 6 equals 0.
2x minus, so the numerator, the top, right? So we set that equal to 0. We add 6 to both sides. And this will be a point on our x-axis, and it's the only point on our x-axis we're allowed to touch at all. Okay, step 3, we need the vertical asymptotes, right? So, we'll set the denominator equal to 0. And what type of equation is this? You recognize that? But we could just factor out an x. And then we set each of those factors equal to 0. Get 2 answers, 0 and 5. Any questions there? What are those on my graph? 0 and 5. I have 2 answers. What are they on my graph?
Your vertical asymptote.
Verticals. And now I have 2 of them, don't I? It's the first time that we've seen this. We've not seen this before. We actually have 2. It's an interesting looking function. Okay, step 4. The horizontal asymptotes. So the powers, the highest power of x. On top, you have 1. What's the degree of the bottom?
2.
Highest power, 2, right? 2. Okay, so what happens in that case? Let me go back to the steps. What happens? Let's see, if the numerator's degree is smaller than the denominator, is that what we have? The numerator was 1, the denominator was 2, right? So the numerator is smaller than the denominator.
Yes.
Then the x-axis is the horizontal asymptote, the x-axis. You understand that? So from this, I know that the x-axis is my horizontal asymptote. So you do not have to look at the numbers in front, okay? Do you all notice that? I'm not looking at the numbers in front because in this case, the degree of the top is smaller than the bottom. The only time I look at the numbers in front is if they have the same degree. It's the only time. All right, it's time to draw. All right, here we go. I'm going to start with my x-intercept of 3. That's on my x-axis, and it's a dot. 1, 2, 3, boom. I'm going to do it in blue. There it is. Okay, so that is the only point that I know exists on my graph. All right, next thing I have are vertical asymptotes. I have them at 0 and at 5, and these are vertical barriers. So let me see here. Here's 4, here's 5. Let me go ahead and do a vertical barrier here. Then I also need a vertical barrier at 0, which is kind of hard to draw a dotted line on top of a dotted line or on top of a line. So sometimes I'll do little dashes like so you can really see it. Okay. One more thing to put here, and that's the magnet that pulls my function out at the ends. And it's the x-axis itself, but I'm only going to draw it on the edges. Any questions on that? So, kind of good news, I guess. On your test, which is really your final exam, which is going to happen next Wednesday, I did right here, just to this step right here. I think I'll give you 9 points out of 10. Let's say this problem is worth 10 points. I give you 9 points if you can do this, okay? I will give you bonus points if you can get the graph drawn properly. So if you draw it properly, I'll probably do it. Does that make sense? Like bonus? Because the graphing, this final part is the hardest part, and we really just don't have the time that we need to really get deep into this. So if you can just get this set up. Yeah. Sound okay? All right. This is where things are really, really difficult. Because right now, the only part of the graph that you know of is that 3 at 3 right there. So does it could do something like this to the left. It could go up like that, couldn't it? Right? But on the right side, it could do like that. It could also do this. The opposite way. This side down and this side up, and these gone. So there's these different possibilities of what it could be. And there's only one way to get around it. It's not going to be fun, all right? That's why I'm going to look at this as being like bonus. The only way to figure out exactly what's going on in here is to pick what we call test points. So like, let's say we take that number there, I'm going to circle it, and we take the number in between 3 and 5, like the number 4. And what we do is we take those and we plug them into the original function. So that means you take this function up here and you plug 1 in and see what you get. I'm going to do that right here. What happens when I plug in 1? Get 2 times 1 minus 6 over 1 squared minus 5 times 1. And when you do that, you should get negative 4 over 1 minus 5, negative 4. You should get positive when you do that. Now, I'm kind of trusting that you could do that on your own. You're just plugging 1 into the function. I get 1 out, which means that the point is somewhere up above, right? It's positive 1, so it's up. Then I do the same thing for the next test point. I plug in 4. When I plug in 4, I get 2 times 4 minus 6 over 4 squared minus 5 times 4. So we wind up getting on top, what is that? 8 minus 6 is 2. And on the bottom, you get 16 minus 20, which is negative 4. Oops. And that you have a negative number there, right? 2 over negative 4, it's a negative number, which tells you that your dot is going to be down below the y-axis or x-axis. And so now with those two together, you know that this graph must come like this and turn up and go like this and go down. Do you see how that's an extra tedious step that you have to do? Do I have any questions on that? Do y'all agree that rational functions are not fun? They're difficult? A lot going on
Yeah.
here.
And you pick the 1 and the 4 just because they're 2 points on either side of that 3.
Yeah, they're on either side of the 3, but also between those dotted lines. You know, so I kind of wanted to know what was happening to the left of 3, but before I get to the dotted line. So I wouldn't have wanted to pick something way down the road, if that makes sense. Yeah?
So could you have picked 2?
Yeah, that makes
I could have picked 2. Yep. And so these points, we call these test points. You get to choose them, but you just got to make sure that there's some valuable information, right? Like it wouldn't have made sense for me to plug in 10. If I'm trying to figure out what's going on right in here, it wouldn't have made sense to plug in 10 because that would have been way outside and that's not what I'm looking at, right? I'm looking at what's happening near 3.
Okay.
Okay, so we have that part of the graph. What we still don't have are the 2 outside. Put our attention on this side over here, okay? What we know is that we have a magnet, right? That magnet should pull my function down towards it. But it could also, the function could be coming in from the bottom like that. And remember, you can't cross the x-axis. You're not allowed to. So the graph is either going to go like this and turn up, or it's going to go like this and turn down. It's one or the other. But the question is which one? So guess what you're going to have to do to figure out which one? What did I just do?
Test point?
Test point. I'm going to need another test point. I'm going to have to plug in any number I can think of over here. So yeah, in fact, I will plug in 10, right, this time, but that's because I want to know what's happening over here. I'm going to take 10 and put it into the original function. This is so tedious. Plug in 10 into the original function. It was 2 times 10 minus 6 over 10 squared minus 5 times 10. That you get 20 minus 6. We get 14 on top, and on the bottom, we get like 100 minus 50. You're going to wind up getting like 14 over 50. And all that matters is that it's positive. And that means that you have a dot above the x-axis. And once you have that dot above, you know that's the left. It's going to have to go and turn up. And to the right, it's going to have to flatten out. We're almost done. What do I say? What's going on over there? So what do you think I'm going to need to do? You're not going to like it, but
could do like
Another
-5, plug in a -5 or negative.
yeah, let's go with -5. Yeah, we'll go with -5. So another test point, -5, and plug it in. So I'll do it over here. F of -5 is 2 times -5 minus 6 over -5 squared. You have to be careful there because you're squaring it. Minus 5 times -5. That's a little weird. You're going to get -16 on top. And you get 25. Wait, I messed something up there. Oh, wait. -5. The bottom is 25 plus 25. So -16 over 50. That's the negative number. So that means at -5, you have a dot down here somewhere. Now, once you have that dot, you know what happens left. Left, you have to go towards the magnet. And to the right, well, the barrier's in the way. You have to go down. Why can't you go up? So that is the graph. Yikes, huh? Messy. Messy, messy.
So you have to figure out like 3 separate graphs for each. I guess I'm confused about why you had to do it 3.
Because I want the whole picture, right? Like I didn't want to do just the inside piece here. Like I didn't want to just know what was happening in there. That would be an incomplete graph because that doesn't tell you anything that's happening on the edges. That just tells you what's happening between those dotted lines. So I had to look, you know, to the right of that little section and to the left of that little section to see if I could put it all together. So I found a test point over here that was positive on the right. Left, it forces me up. To the right, it has to go towards the magnet. Then I went to -5, found the negative value came out. So the magnet right has to drop down. So we want a complete picture. Now I know what the graph looks like all the way from the left, all the way through to the right. Does that answer the question?
And yeah, it does. And will it always be like 3 separate graphs?
No.
It's like, you know.
Yeah, it's every single one of these is different, which is what makes these so hard. Is that, I mean, right now, the reason we had is because we had 2 verticals, right? 2 vertical asymptotes, and that broke our graph into 3 sections, right? If you draw 2, if you have 1 vertical line, you're gonna have 2 sections. If you had 3 vertical lines, you're gonna have 4 sections, right? Now, I expect for you in this class, you will not have more than 2 vertical lines. I won't give you a problem that has more than 2, all right? In a traditional college algebra class, you could have as many as 4. So we're keeping it kind of toned down, but it could be this case. Okay, let me do one more. After I do that, I think I'm going to give you work in groups. I mean, there's only 11 of you in here, 10 of you in here, so I'll let you work on these in groups. All right. So this last example. Let me think. All right, so what's the first step? Is it rational, right? It is. Second step, we want to find the X-intercepts. To do that, we set the numerator to 0. So we set the top to 0. What type of equation is this that we're looking at? Quadratic, yes? So if I'm going to factor it because it does factor pretty straightforward. Not showing the work here. -8 and +1. Is everyone clear that you could have got those answers also? What are these on my graph? What are these? They're X-intercepts, right? So when I draw them, what do they give me?
They give you 2 points on the x-axis.
That's it, right? 2 points, that's it. Okay, 2 points on the x-axis, that's all of them. Now, step 3, I want the horizontal asymptote. I'm sorry, vertical asymptote. To do that, we set the denominator to 0. And we just subtract 4 on both sides, we get x is negative 4. That's our vertical barrier, and we only have one of them. So that means we're going to have 2 sections to draw, one on each side. The fourth step is our horizontal asymptote. So the degree of the numerator here is 2, and the degree of the denominator is 1, right? In the denominator. Let's see what happens when that's the case. If the degree of the numerator is bigger than the degree of the denominator, that's what we have. We have no horizontal asymptotes. What that means is we have no magnets. Things pulling our function out at the ends, and you'll see what that's going to mean when we draw it, okay? But we have none, okay? No horizontal asymptotes. No horizontal asymptotes. All right, so I have X-intercepts. Those are dots. I have one at -8. Positive 1. I have a vertical asymptote, right? A vertical barrier, and that's at -4. That. I have no horizontal asymptote, so I'm not going to draw any horizontal edges. Okay. It's time to draw. So imagine that you're standing here at this -8 right here, and you have to draw to the left. You have no magnet telling you which way to go, right? You have no dotted line that's telling you where you should go. And if you don't, then the function acts more like a polynomial. And remember, polynomials only do, up or down. So anytime a rational function has no horizontal asymptote, you're either going to go from this point and go up, or you're going to go down, one or the other. So how do you think we're going to figure out which one it is, up or down over there?
Plug a point.
Plug a point in, test points. This is why on the test, I'm going to give you like 9 out of 10 points if you get this drawing right here, because this is the part where I want you to feel like you get that other stuff, you can do well on the problem, but this part's not going to kill you, this test point part. So I want what's going on over here at -10, let's say. I could have picked any number over here, -11, -12, -20. I need to plug things in. And that's going to suck, man. Isn't that going to suck to plug -10 in there? F of -10 is -10 squared plus 7 times -10 minus 8 all over -10 plus 4. That just sucks. So this is out to be 100 minus 70 minus 8 over -6. Now, all you care about is whether or not this is positive or negative. That's all we care about. So if I take 100 and subtract 70, I'm going to get 30. And if I take 8 away from them, I get 22. So I have a positive number on top and on the bottom a negative number. So I'm going to get a negative number out. So that means on my picture, at -10, I can put a dot down here. I mean, we know it does this, and we know it goes down forever. But now I need to draw to the right. So if I continue to draw to the right, what's going to happen here? Barrier forces me up or down?
Up.
Up, got to be up. Can't cross the x-axis. Okay, now on the right-hand side, I don't know if it does that or if it does that. So I have to pick a test point. And maybe a good test point would be, I don't know, the number, oops, I didn't mean to do that. Maybe, I don't know, 3 or something, plug that in. No, I'm not going to do it. I'm going to save us some time. It would turn out to be positive. And that means that this thing is going to go like this and through and up forever. And as I draw it to the left, it's going to come to the barrier and it's going to force it down. So that's the graph. It's not nice. I mean, these things are messy. So I know you sit there and you're like, you know, why in the hell are we graphing rational functions? Like, so all I can say is, you know, go back to what I said at the beginning of this class, and that is, you know, this is not about graphing functions. This is about, you know, can you carry out a procedure? Can you carry out a process? And in that process, also demonstrate some skills and some arithmetic skills. That's what this is about. Just developing parts of your brain and process information and go through procedures a certain way. You'll never in your life have to graph a rational function by hand other than in this class. But it's a procedure, all right? So I think what I'll do is I think I'm going to put up 3 problems. I'm going to leave y'all all in here together. I think that maybe might not be enough to go into groups, but I'll leave y'all in here together. You can work in math, but I'm going to leave the steps up. That's why I want to leave the screen so everyone can see it. So let me go back to the steps. And then I'm going to just kind of squeeze in here the 3 options. So the first one, let's do f of x equals 4x minus 12 over x plus 4. The second one, f of x equals, how about 4x over x squared minus 9. And the last one, f of x equals, oh, this will be good. Let's flip that one over, x squared minus 9 over 4x. First thing I want you to do is on each of these 3 problems, go through 3, 4, 5. Remember I said the part that will get you like 9 points out of 10, like draw the x-intercepts, draw the horizontal and vertical asymptotes, do all that, and then move on to the next problem. Do the same thing, get all 3 of them done, and then if you finish that, go back and try and draw the final sketches. Does that sound good? I think if we do it that way, there's enough time left here for each of these problems. Any questions? Okay, I'm going to give you, I don't know, let's see how much you get done the next 20 minutes. I'll check back in 20 minutes. If you have a question, in the meantime, if you have a question, just let me know. I'm going to just step away and get a drink, but I'll be right back. I was wondering if you all would like me to start working these below without giving you any verbal information, just to work them.
Yeah.
That way you can kind of check what you're doing. All right. Okay, I've shown what I would expect you to get 9 out of 10 points right there. I'll leave that up for a few more minutes, let y'all keep working. I think that that's probably enough time. Do y'all have any questions over this? Any of the work that I have here?
So for the number 2, I actually put on the step 3, I had put x open parentheses x minus 9 and then close parentheses,
Mm-hmm.
and I got it wrong. But how do I?
Oh, like you factored an X out.
Yeah,
So I think what you said is you had X and then X minus 9 like that. Is that
yeah,
right? Okay, so look, if you distribute that through, X times X is X squared, and then X times negative 9 is negative 9X. So you factored an X out and there wasn't an X to factor out on the 9.
yes.
So you have to recognize that as being a difference of squares, and that's where it factors out like this. Do you see the difference?
Yeah, I get it.
Okay. Yeah, had there been an X there, like I just put it there, had that been an X, then what you did would have been correct.
All right.
Are there any other questions? To do for homework. And then when we come back on Wednesday, we won't go through all of these answers for the 3 homework problems. But also take these problems and the homework problems and try and see if you can graph them, like drawing the missing pieces. And we can talk more about that on Wednesday. And then we'll also discuss exponential and exponential functions, and we'll see if we get to log functions. We'll see how things go. And that'll be all we cover. We'll be done for this semester. And then Monday, again, will be a review. So here's 3 problems. Let's go. That over. There you go. Make sure you can at least draw the pictures the way that I had drawn the pictures for those 3 examples we just did. You can get that set up first. And I think that'll do it. We'll call it a day. We've only got about 9 minutes left, so I'll leave that up there and let y'all copy it down. You can leave whenever you're ready. Y'all have a good day. Yeah, go ahead. Yeah.
Well, no, I was wondering if you could just do one of the problems we just did, just like do the rest of it.
The drawing? Yeah, which one do you want me to do? Which one?
How about number 1 will work.
The one? Okay, so let me just draw it over here. Okay. So we've got. Okay, we've got a horizontal asymptote here at 4. And then we got vertical asymptote at -4. X-intercept at 3. Okay, so let's start with the only point that we know that actually exists on our graph, which is 3. And we know that we have a magnet up here. So we know we've got to come up and go like that. Do you understand that? Agree with that?
Yeah, I got it.
Now, we can also, this is where test points come into play. The more test points you have, the more accurate your drawing is going to be. So like right now, I kind of don't know what's happening in this region right here. So what I could do is I could test a point, any point that I want. So a good point in here would probably be the point 0. If I plug 0 in, it's going to tell me where I am. I could also pick a test point over here, like maybe -6, and that'll tell me kind of what's happening in this region. Do you see what I'm doing? The only thing I knew for sure is that from 3, it had to have gone up to that magnet. That's the only thing I know for sure. So that's why I drew it. But the rest, I'm going to use 2 test points. And I'm going to actually plug those in to the original function, which is up here. So I'm about to plug in 0 and -6. I'm going to do it up here. Give myself some room. So let me plug in 0 first. That should be pretty easy to plug in because that'll just give me -12/4. That's -3. So I know when I plug in 0, I get a negative number. So let me go back to my graph here. When I plug in 0, I have a negative number. I'm down here. Doesn't matter really where you put it, just put it down. And that means that when I draw this, it's going to have to go here. And as I keep drawing, I have the barrier, which forces me down because I cannot go up and cross the x-axis. Does that sound okay?
Yeah.
Okay, and now let me try plugging in -6. And that should give me an idea of what's happening over on the other side. -6, so 4 times -6 minus 12 over -6 plus 4. So 4 times -6 is -24. Take away 12 over -2. This is like -36 over -2. That's a positive number, isn't it? Positive. It's actually like positive, what, 18 or something. So what I know is that my dot is up above here, right? So I know that I have to go to the left. I have to go towards that magnet, right? To the right, though, what has to happen? Be careful on this. What has to happen to the right? Going to hit that barrier, right? So
Yeah, the barrier, but it also can't cross the x-axis.
that's right. Can't cross the x-axis, which means it has to go up, right? Now, that's why it's so important to draw these dotted lines over at the edges, because that dotted line is not telling you can't cross it like further inside the graph, which is what I just did. If I had continued that dotted line across, then you might think that you can't cross it. That's why I have not told you to draw it all the way across. I said draw it only on the edges. So that's it right there. That's your picture. So I would say when you're doing these problems and going back and trying to piece it together, the more test points you have, the more likely you're going to have the correct graph. The problem with the test points is that they take a little while, right? Like you actually have to sit there and plug them in, make sure you don't make any mistakes. It's time consuming, but it's worth the effort because it really gives you a better idea of what's happening with the graph. Does that help?
Yeah, it helps. One more real quick question on the next one. Your vertical asymptote. What's it called?
Vertical asymptote. Yeah.
Asymptote is a 0. So you're going to start out at the
Wait,
X-intercept.
which one are you
which is
talking
0.
about? Number 3?
Sorry, number 2. No, number 2.
Okay, you have an X-intercept at 0,
Yeah,
not a vertical asymptote. Yeah,
or a horizontal asymptote
at 0. Yes,
right?
horizontal this way. Yes.
Yeah, that's what I meant. So that horizontal asymptote's gonna act like a magnet for your
Function.
for your
Yeah.
line.
Yeah.
So you start out at 0, and it's just kind of going to run along that.
Well, you don't know what it's going to do. That's what I'm saying. Like this problem here, you really don't know where to go. Like with this dot to the left, like you're not, like you don't know. Maybe you do that, but then maybe you do this. And this way, maybe you do that, or maybe you do this. And then over on the left side, you could be a magnet like this and then have to go up, or you could be a magnet like this and then come this way and have to go down. And same with the right side, you could be a magnet and then have to turn up, or you could be a magnet like this and then have to turn down. Do you see how it could be like all of those different possibilities?
Yeah, I see. I just didn't know if that horizontal would, at 0 would draw it down regardless. But so you just plug in points.
Yeah, if I were doing this, I would probably be looking at, let me show you that if I were doing this problem, I would pick a test point of 1, and I'd pick a test point probably of 5. And then I'd pick a test point of -1. Notice I'm circling my test points. That way they stand out, and then I could plug one -5 here. And that way I've got 4 good test points. When I plug those in, I'm going to plug them in just mentally. 1 goes in 1, you get a negative number. So if you plug in 1, you'll get a negative number. If you plug in -1, you're going to get a positive number. If you plug in 5, you're going to get a positive number. And if you plug in -5, you're going to get a negative number. So I just did those real fast in my head, okay? But those are the 4 points I would have. And once I have those 4 points, I know that this dot has to come here and connect and go up. This has to connect, and then the barrier is going to send me down. Over to the right, I'm going to have a barrier that sends me up, and then to the right, I've got a magnet down. And then over here on the left side, I've got a magnet over there, and then drawing it to the right, I have to go down. I know I did that fast, but does that all kind of make sense how I went through that procedure?
Yeah, it does. It does.
Okay. And you know what? I mean, while I'm here, I may as well just do the last one, just so you have the picture of it. So last one, if I were doing this problem again, I need test points. I just don't know enough about what's happening. So I probably pick 1, so I would have an idea what's happening in this region, okay? I'm gonna pick maybe 5. That way I know what's happening at the end. And then I'll just do the same thing on the other side, -1 and -5. And then I have to plug those in up there. So let me start with 1. I'll get negative if I plug in 1. If I plug in 5, I'm going to get positive. If I plug in -1, I'm going to get positive. If I plug in -5, I'm going to get negative. So when you draw this, just start connecting the dots, like here to here, here to here. Now we have no horizontal asymptote, which means it's going to continue to go down. And then I have that vertical barrier, which sends me up because I can't cross the x-axis. And on the other side, I connect these 3 dots together, and it's kind of the same story. The right side's got to go up, and on the left side, I'm going to have to go down because of the barrier. So like when you go back and, oh, go ahead.
Much better idea. Oh no, I was saying that much better. Like there.
Okay, yeah. I think you were kind of cutting out, so I think you said it's much better. It makes more sense now.
Yeah, you answered the question. So.
Okay. So when you think back now and you think about when we started graphing things in this class, the first thing we started with was a line, which are very basic functions. And then we went to quadratics, parabolas and all that, vertex, and then we went to polynomials that went up and down, a little more complicated now. Look at these. I mean, rational functions, they don't look even like each other. Like one rational function can look completely different than another rational function, but they all have the same property. They're polynomial over polynomial. So the graphing of them is difficult, but I would just say, more test points, the better off you're going to be. All right.
Okay.
We'll call
Thank-
it. Good. Okay. All right. Y'all have a good day.